Hello, that was the end of the polar form section. You can try this exercise. You can find it in the resources section of this lecture. Once you're finished, you can continue the video and find the solutions. You can also download the solutions and look at it on your own. You can pause the video now. Let's look at the polar form solutions. Question 1. Given z equal to root 3 plus 2i, then the modulus of z is root 7. The argument of z is 49.11. Therefore, in polar form, z is equivalent to root 7 into cos 49.11 plus I sine 49.11. Hence, z to the 6th power is equivalent to 143 minus 312i. Question 2. First, we draw the complex number z1, which is 5 plus 2i. According to the complex number z2, we have to magnify this by 3 or scale it up by 3, then rotate 90 degrees counterclockwise and multiply it by 1. So 1, 2, 3, rotation counterclockwise, multiply by 1, and the result of z1 multiplied by z2 is 13 plus 11i. From the Argand diagram, the complex number in Cartesian form is z1, z2 equal 13 plus 11i. The modulus of z1, z2 is root 290. The argument of z1, z2 is 40.24. Hence, z1, z2 in polar form is square root of 290 into cos 40.24 plus I sine 40.24. Question 3. Given that z1 is equal to 5 into cos pi on 4 plus I sine pi on 4 and z2 is equivalent to 2 into cos pi on 4 plus I sine pi on 4, the modulus z1, z2 is equivalent to 10. The argument of z1, z2 is pi on 3 plus pi on 4, which is 7 pi on 12. Hence, z1, z2 in polar form is 10 into cos 7 pi on 12 plus I sine 7 pi on 12. If we draw the complex number z1, we can see it is enlarged by 2 and it is rotated through an angle of 7 pi on 12 clockwise. Number 4. Given z1 equal to 5 minus root 5i and z2 equal to 3 minus root 3i, the modulus of z1 over z2 is root 5 on 2. The argument of z1 over z2 is argument of z1 minus the argument of z2. Hence, we get that the argument of z1 over z2 is 6. Therefore, the polar form of z1 over z2 is equivalent to root 5 on 2 into cos 6 plus I sine 6. The modulus of complex number z1 is reduced by 1 on root 2 and is rotated through an angle of 30 degrees anti-clockwise. Number 5. Given z is equivalent to cos theta plus I sine theta raised to the 4th power, then using de Moivre's theorem, z is equivalent to cos 4 theta plus I sine 4 theta. Therefore, x is equivalent to cos 4 theta and y is equivalent to sine 4 theta. Using the binomial theorem, we are able to get that z would be equivalent to cos to the 4th power theta minus 6 cos squared theta sine squared theta plus sine 4 theta plus I into 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta. To get tan 4 theta, we take sine 4 theta and divide it by cos 4 theta. We then divide the top and bottom by cos to the 4th power theta and reduce it to get 4 tan theta minus 4 tan cube theta over 1 minus 6 tan squared theta plus tan 4 theta. Number 6. Given z is equal to cos theta plus I sine theta, then z1 plus 1 over z1 is equivalent to z to the power of 1 plus z to the power of negative 2. This is equivalent to cos theta plus I sine theta to the power of 1 plus cos theta plus I sine theta to the power of negative 1. z1 plus 1 over z1 would then be equivalent to cos theta plus I sine theta plus cos theta minus I sine theta. Therefore, z plus 1 over z is equivalent to 2 cos theta. Following the same principles as before, we are able to obtain the solution of 2i sine theta for z minus 1 over z. And that's the end of the solutions.